Alrighty, yet another day of factoring. We're going to look at another type of problem we could see. Today we're looking at problems where the last term is negative. So in this case, we're still wanting to factor as two linear binomials, but if I put two positives here, they would multiply to be positive. If I put two negatives here, they would multiply to be positive. So this is a case where we need one positive number and one negative number. So again, recognizing your signs should help you factor here. And again, we're looking for factors of negative 12. And we want them to have a sum of the coefficient of the middle term, which is negative 1. So we're looking for two numbers that multiply together to get negative 12, but add together to get negative 1. So as always, if I were just doing 12, we could always do 1 and 12. We need one positive and one negative. In this example, I'm once again going to do more work than I would typically do. And if you can do less work than I'm doing, that is totally fine. But I'm going to try to fully display this to you. If we did a negative 1 and a 12, they would have a sum of 11, which is positive, but we're looking for a negative sum. So we actually need the number with the greater absolute value to be the negative 1. Negative 12 and 1 would have a sum of negative 11. That's not negative 1, so this isn't correct, but it is at least negative. We could do 2 and 6. Again, one positive, one negative. Negative 2 and 6 makes 4. I know the bigger one really needs to be negative, which would be negative 4. That's still not correct. We could do 3 and 4. If I do negative 3 and 4, that gives me 1. I want a negative 1, so that means I need to do 3 and negative 4. So that tells me that this factors down as x plus 3. The 3 needs to be positive, times x minus 4. The 4 needs to be negative, because 3 times negative 4 multiplies to be negative 12, and 3 plus negative 4 adds to be negative 1, which is a coefficient when there's not a number written, like in that negative x. And again, the order doesn't matter, so as long as you have the 4 being negative and the 3 being positive, you're in good shape here. Okay, let's do another example like that one. All right, so in this case, the negative 63 is negative, but the 2 is positive. So I'm looking for factors of negative 63. And what those factors have a sum of. We could do 1 and 63. I am going to save a little bit of work for us here, though. We know this needs to add to be positive. If I made the 63 negative, their sum would be very negative. So I want the smaller absolute value this time to be negative. So they have a sum of 62. We're pretty far away from this. So then 2 does not go into 63. 3, however, will 21 times. Again, we want the smaller number to be negative this time, so that has a sum of 18. Still not there. 4 does not go into 63. 5 does not go into 63. 6 does not go into 63. But 7 will 9 times, and negative 7 and 9 have a sum of 2, which is what we want. So this factors down as x minus 7 times x plus 9, or x plus 9 times x minus 7. Make sure you have your signs right, otherwise the order does not matter. And there's our answer to example 8. And I'm going to do one more problem today, and then we're going to have one more day of this in our next video. Factor x squared minus 4. This problem looks different if we compare it to the last problem. It starts with an x squared and it ends with a negative number, but we do not see our middle term here, which means our middle linear term is 0x, whereas here we had a 2x. In example 9, there is not a middle term, so we want a sum of 0. So we could look at the factors if we'd like. Factors of, we want to multiply to get negative 4, and again get a sum of 0. But of course, 1 and 4, if I make the 1 negative, that's a 3. If I make the 4 negative, that's a sum of negative 3. That does not work. There's no way for me to have a sum using 1 and 4 to get 0. So we're going to have to use the pair of 2 and 2. And since those are the same number, it doesn't matter which one I make negative. 2 and negative 2 will have a sum of 0. So really, any time that you have a middle term of 0x that you can't see there, that isn't represented, your two factors are going to be the same number, one positive and one negative, if it is factorable. So if this is a perfect square, this is a special case called a difference of squares. We've got 2 and negative 2 in this case, same number, one positive and one negative. So this factors as x plus 2 times x minus 2, or x minus 2 times x plus 2.